Scientific discoveries are coming at breakneck speed from all fields, and November continues that trend. So here are 10 new scientific discoveries for November 2024. Number 10. The Lake Michigan Holes. It never ceases to amaze me about this, but it's actually true when it is said that we know more about space than we do about Earth's oceanic environments. We have a lot of work to do with the aquatic environments of this world. It's more than just the oceans, and that's not even getting to the aquatic environments of other worlds within our star system. The moons like Europa and Enceladus and many others that seem to harbor subsurface oceans. But the great freshwater lakes of Earth also hold aquatic mysteries that have yet to be solved, and even more perhaps that remain to be discovered. One of these is Lake Michigan. We actually have mapped the surface of Mars to much higher resolution than we have the bottom of Lake Michigan. Recently, NOAA researchers working in the Wisconsin Shipwreck Coast and National Marine Sanctuary discovered a group of sinkholes in Lake Michigan. This is not unheard of. Similar sinkholes have been found at the bottom of Lake Huron, and the Huron sinkholes actually have some very interesting microbial environments going on. This also seems to be the case with Lake Michigan. Officially discovered with sonar, the Lake Michigan sinkholes stretch for miles, and some of them had been noticed previous to this by shipwreck explorers. The researchers confirmed that they were in fact natural sinkholes and lie at a depth of about 450 feet, just off the coast of Sheboygan, Wisconsin, extending north in a line. They average between 300 and 600 feet across, and mostly are nearly perfect circles. And they currently total about 40 known, but there are likely more. What happens is that groundwater dissolves the bedrock, and the whole thing collapses into a hole, by first groundwater creating a cavern in the limestone strata until the cavern collapses, thus the sinkhole. This type of situation should be fairly dead. It's cold and the water is low in oxygen. So much of Earth's life that exists in lakes cannot exist here. That actually serves to preserve wooden shipwrecks in the Great Lakes. But it's not completely dead. Freshwater shrimp, perhaps disturbingly known as opossum shrimp, and a certain small fish known as a deep-sea water sculpin live there, along with invasive, nearly indestructible, non-indigenous quagga mussels, and lots of microorganisms can still survive under these conditions. But it's still unknown just what types of microbes are down there. There are certainly some types of cyanobacteria that actually compete across the day for sunlight with another group of bacteria in a kind of dance of survival. But the groundwater meeting the lake water is interesting because it's a bit different of a sulfur-rich chemistry than what might usually be expected. What else lies in the depths of these sinkholes to discover remains to be seen. I wonder what else lives there. Number 9. The mildly intoxicated hornet. The species Vespa orientalis is a type of hornet that has a diet consisting of nectar like many insects, but also likes ripe fruit like grapes. The thing is, fruits contain sugars that naturally ferment into ethanol, the same alcohol and process that wine is made with. Lots of animals actually do eat fermenting fruit, but they usually can't handle more than 4% ethanol, and one wonders what they feel like the morning after eating a lot of that. But the hornets were different. They had an alcohol tolerance that was through the roof and could handle up to 80% without their behavior or lifespan changing in the least. And that 80% solution was artificial. It's 4 times more than what is found in nature with fermentation. You would think these hornets would be dropping out of the air and wallowing on the ground before passing out, but they don't. And the answer seems to be their genetics, in that they have a gene in great abundance that functions to break down alcohol. So the hornets process it very rapidly, and more, within their digestive tract, brewer's yeast was found to be active, which also helps here, and is what is used to brew beer. This adaptation allows the wasps to eat fermenting fruit that's too far gone from most other animal life, and process it much faster, opening up an actually very nutritious food source, as ethanol can be nutritious in this case when broken down, so long as the intoxicating effects are negated. Number 8. Dinosaur feathers were useful. Over the course of my life, as new discoveries in paleontology have come to light, our view of the dinosaurs has changed dramatically. What I saw in books in the early 1980s, lumbering, oversized reptiles like T-Rex dragging its tail, are now seen as dynamic, hot-blooded arch predators with stereo vision and amazing complexity, which to me makes them that much more scary. I would not want to run into a T-Rex. And then came the feathers. It's now known that some dinosaurs, T-Rex included, had at least partial feathering, further bolstering their already strong link to modern birds. But what function those feathers had with an animal like T-Rex wasn't all that clear, until now. Very small 120 million year old fossil tracks have been uncovered in South Korea that seem to paint a picture of this. The dinosaurs and the birds split before this, and dinosaurs themselves that had feathers did not seem to possess wingspans that would have allowed flight like the birds. But the feathers may have been more useful than just for show and reproduction. The tracks seem to suggest that whatever dinosaur left them, thought to be a small raptor, could cover an unusual amount of ground in gliding leaps assisted by their feathers, and probably also could break and turn and do all sorts of things with them, giving us further insight into the age of the dinosaurs and what was really going on. Again, not sure I would want to come up against a small, aggressive dinosaur with teeth that could glide like that. Number 7. The Mars Battery. Batteries have always been problematic, though they are getting better. We've used them for decades and improved them, but that took a lot of work to perfect, and there's still room for more. That's sort of a problem for space exploration because batteries can recharge, often many times these days. But it remains imperfect, and on something like a Mars colony, battery replacements are going to be challenging unless you can make them on-site, instead of endlessly transporting new ones from Earth. Until now, scientists in Switzerland have come up with a surprisingly standard battery design that has the usual 2 electrodes, but instead of making them out of metal, they made them out of graphene. Instead of filling the space between the electrodes with lithium salts or something like we would normally use, they merely used clay and water. Both of these are available on Mars in abundance. Turns out this battery works. They were able to produce a battery that yielded 1.6 volts and could be charged and drained 60,000 times before starting to lose efficiency, and very surprisingly does not need to use relatively scarce materials like lithium. Not only is that important for future battery manufacturing on Earth, but this could also be done on Mars, potentially mitigating or eliminating a resource and manufacturing problem on Mars that once seemed pretty challenging. Number 6. Scamming artificial intelligence. When we look at the large language model-based chatbots that are becoming so ubiquitous today, humans often use them to attempt to scam other humans. That's going to be an increasingly problematic effect of AI from here on out, expect it. But a group of researchers in AI decided to try a different approach. Could a human scam an AI chatbot? And the answer is yes, and it wasn't all that difficult. What happened is researchers basically presented scam scenarios to popular LLMs to see if they would bite on things like non-existent new cryptocurrencies, and asked if the AI would buy it or not at ridiculously low prices, something most humans would see right through in a minute. They then upped the ante by making the scams increasingly complex and making it seem as though the input was very knowledgeable on the matter, and other techniques that might lull the chatbots into thinking they were talking to someone persuasive for whatever reason. And they fell for it, but to wildly varying degrees depending on the LLM being used. Chatbots will no doubt get better at spotting scams, but for right now, do not trust one for financial decisions. They aren't that great at that yet. I stress, yet. Number 5. A new volcano at Io. Io is wildly volcanic, ridiculously so. This is because that moon is located so close to Jupiter that it is constantly flexed by the gravity of the gas giant, causing a lot of heat, and that heat translates to volcanism. Io is old, and is likely to have been in this volcanic state for much of the last 4.5 billion years. Its surface also shows evidence of constant volcanism going on, and Io has been photographed with various space probes to host erupting volcanoes dotting its surface constantly. One interesting thing, however, is that a lot of these features appear to be very young. Io is not the heavily cratered ancient surface that we see with places like the Moon or Mercury. But now Io has been caught in the act of forming a brand new volcano. The first highly detailed photographs of Io were taken by NASA's Galileo spacecraft, though there were previous photographs taken by other probes. Galileo regularly photographed this moon between 1995 and 2003. The Galileo mission ended, but now there is a new spacecraft in the Jupiter system, the Juno probe, resuming photography of Io, and what's interesting is to contrast the new photography with the old photographs taken decades ago and look for changes. The changes to Io's surface have been rather pronounced, and in particular a new active volcano has formed. Known as Kanahakili Fluctus, this volcano is currently showing 2 active volcanic streams of lava stretching 100 kilometers, and deposits of red sulfur covering a large area to the east of the volcano. Other changes were noted that have happened over a period of months, including a very large red ring forming around another active volcano, indicating a huge volcanic plume having occurred between passes of Juno. Io is very active indeed, and very well may be the most dangerous solid surface in the solar system on which to set foot. Perhaps Arthur C. Clarke should have said, "All these worlds are yours, except Io. Attempt no landing there. Too dangerous." Number 4. More Beetlejuice drama. Beetlejuice is a very misunderstood star, and it tells us so. From belching out giant clouds of carbon and visibly dimming right before everyone's eyes a few years back, to lingering questions of just when the star could go supernova, we actually still know surprisingly little about this star, despite it being one of only a handful of stars close enough and giant enough for our telescopes to actually be able to resolve into a disk rather than just a point, as with the vast majority of stars when visually photographed at high magnification. And the drama has deepened with this star. I shall refrain from saying its name for the remainder of this entry, however, as saying it 3 times will either cause actor Michael Keaton to appear in the Event Horizon studio, in which case I would immediately go into interviewer mode and forget to finish this video, or the star would show up and that would not be good. It turns out Beetlejuice appears to have a companion star, and the star is really, really unlucky. 2 studies have shown that Beetlejuice has a companion star about the size of our sun that orbits it every 2100 days, and it's linked to a pattern in Beetlejuice's brightness variations. That was the 3rd time I said it, and nothing happened. If the existence of this companion star is confirmed, that orbit is not stable. It's shrinking, and in about 10,000 years, Beetlejuice will consume this star. What that means for its supernova status and when that will happen is anyone's guess. Very dynamic, that situation, at least on the timescales of the universe. Number 3. The Apocalypse of Ganymede. Ganymede is the largest natural satellite in the solar system. Its size is larger than the planet Mercury, but it's less dense. And Ganymede is on the candidate list, a rather strong one, for being an ice shell moon with extensive subsurface oceans that may actually be divided into layered oceans between multiple shells of types of water ice. Beyond that, it also isn't talked about very much in favor of Enceladus and Europa, but there is a very odd feature of Ganymede that isn't well understood, but it may reveal a very violent history for this moon. Ganymede has an extensive furrow system, basically concentric rings of troughs that are suspected to be a very large impact feature. Researchers at Kobe University in Japan have been studying these features in depth and have determined that the center of the furrow system aligns with the tidal axis of Ganymede. This may mean that a giant impact that created the feature also redistributed mass in Ganymede and caused the moon to reorient itself into a different axis alignment. In short, it got knocked askew. The researchers calculated that the impactor had to have had a diameter of 150 kilometers to have done this, which is huge. That's 15 times the size of the impactor that killed the dinosaurs on Earth. Given that it's Ganymede we're talking about here, that impactor would have shattered the icy crust and blew itself into the oceans below, hurling vast amounts of freezing water into space, and forming a weird transient crater for a time, while all that ejecta dropped back onto the surface, altering the local gravity, causing Ganymede to reorient itself, aligning the impact ground zero with the moon's axial tilt. Early in Ganymede's history, something really horrible seems to have happened there, but more data is needed to know more about this. Number 2. A new way to deflect asteroids. Ganymede would have done well if it had bothered to develop a way to deflect giant asteroids, but since it didn't, we'll just have to. We normally think of asteroid deflection in terms of an impact, and that's what we've so far successfully experimented with. So long as we map out any dangerous asteroids and have enough warning, we can now deflect an asteroid if we have to. But there actually may be multiple ways to do it. In the early days of talk of asteroid deflection, the main go-to was a nuclear bomb, but this actually turned out to not be a great idea because it would simply shatter the asteroid into numerous pieces that could end up having the same, if not worse, effect when they hit Earth. But there may be another way here, and that is using X-rays from a nuclear blast to deflect the asteroid without shattering it. Researchers at Sandia National Labs have found that computer simulations and lab experiments show that X-rays emitted by a nuclear blast could actually deflect asteroids, so long as they are relatively small, such as the size of a football field. These blasts could be detonated a safe distance from Earth when the offending asteroid is relatively distant and get the job done without an impactor. This would not work on larger asteroids, but smaller ones that could destroy a large city, yes. What they did was use an X-ray generator to blast a piece of quartz the size of a blueberry in a vacuum chamber for a few nanoseconds, vaporizing the quartz holder, causing it to go into freefall. The X-rays also vaporized the surface of the quartz, causing a gas plume release that pushed the quartz like rocket exhaust at a speed of 250 kilometers per hour, presumably into the side of the chamber. That poor piece of quartz, which scales up to the ability to do the same thing with an asteroid up to 4 kilometers in diameter. Number 1. The El Niño amplification of the end Permian mass extinction. Now that is a foreboding entry title for a list like this, and why I saved it for number 1. The end Permian mass extinction was one of the worst Earth has ever seen, happening about 250 million years ago. This was indescribably bad, ending many marine genera by 100%, including the famous trilobites. But much more to the point, it is also known as the Great Dying. 90% of all species on Earth at the time did not make it through this event. But it's also a complicated mass extinction because it appears to have had multiple contributing causes instead of any single event. It was more likely a poorly understood cascade event than something sudden like an asteroid impact. Basically a perfect storm of death that just happened to come together, but there may now be another clue in unraveling what exactly happened here. And it's El Niño events far stronger and longer lasting than the ones we see today. The trigger does seem to have been massive volcanism coming from the Siberian traps. We see evidence of that. And with that level of somewhat extreme volcanism releasing carbon dioxide into the atmosphere, it would have caused very severe climate effects that caused warming but also devastating deoxygenation of the oceans, hitting marine life very hard. The problem is that these triggers do not account for everything. One aspect here is that land species were hit first, tens of thousands of years before the oceanic life. And there are a lot of hypotheses as to why, such as ozone holes or volcanically induced severe winters, but nothing quite fit. But work with oxygen isotopes in fossils seems to paint a different picture, and a very severe El Niño fits the bill. El Niños happen today when warm water in the Pacific spreads east periodically, and that affects the planet's weather in a cycle. But Earth wasn't in the same configuration as it is today because of continental drift. And during this period, it had a mega-ocean called Panthalassa. That means that an El Niño effect had a lot more surface area to occur. This in turn could easily have dramatically altered weather patterns that killed off forests, which released more CO2 as a result of feeding back and causing the El Niños to get worse until these events were lasting a decade, and the worst of these events coincided with the worst of the extinctions. It pays to remember here that Earth's oceans are no longer configured anything like they were during the end Permian extinction event, and those El Niños were uniquely bad to Panthalassa. Yes, El Niños can have bad effects, and it's probably not a great idea to alter the conditions. But the unique configurations of the oceans in the distant past created these super El Niños that really does make one wonder about any exoplanets we might find that are oceanic, to a greater degree than Earth. If a bunch of things can happen at once to worlds with too much surface area water, and come together and kill 90% of life on that exoplanet, as happened here, then we might want to consider more deeply ideas of planetary configuration and setup as a great filter. Too much water surface area on too young of a planet, and resets may be common. Thanks for listening. I'm futurist and science fiction author John Michael Godier, also branded by some as the Adam West of science YouTubers, currently addressing Michael Keaton again. He really was a good Batman and made some really good movies, including Beetlejuice and The Founder, if you've ever seen that one. But if anyone has seen the new Beetlejuice sequel, let me know what you think in the comments, as I may rent it. I'm usually a sci-fi guy, but I really did like the original Beetlejuice as it was a really fun, quirky movie. And be sure to check out my books at your favorite online book retailer and subscribe to my channels for regular in-depth explorations into the interesting, weird, and unknown aspects of this amazing universe in which we live.